By the way, we have studied the antibody production in this animal assay a long time ago, when we injected zeomine or Botox into rabbits. A group of rabbits, 20 rabbits, were treated with Botox, and the other group, 20 rabbits, were treated with zeomine. That was a vaccination experiment, pretty high doses, so you really cannot compare it to clinical, the clinical situation. We just, or the authors just wanted to analyze, is there any difference in the immunogenicity between the products? So it's more or less a vaccination experiment to really find out, are there antibodies produced? And the serum were analyzed with this hemidiaphragma assay after the end of the stimulation of the vaccination process, and it turned out that in that case 20% of the rabbits which were treated with Botox developed neutralizing antibodies against Botox, against the neurotoxin, and in the case of zeomine there were no antibodies produced. So from this vaccination experiment we draw the conclusion whether there is a difference in the immunogenic effect. And the explanation for that I have given you before. In Botox we have this stimulating proteins, the complexing proteins, which can stimulate the immune system, and this is, at least in the animal assay, a proof for that. Okay, this is an interesting study from the neurological field. These scientists had a range of patients which were treated with Botox or Dysport for torticollis, cervical dystonia. And these patients had developed antibodies against the neurotoxin, so they were secondary non-responder. And they divided this collective in two groups. 37 patients were treated with high doses of zeomine, 200 units, for 5 years, every three months. The other patients were left untreated. And then the titer was analyzed, and they found out that 84% of the secondary non-responder got a titer which was below the initial titer after 48 months. And interestingly, even 62% became seronegative after 36 months. Interesting result, because what you would have expected is when you treat with a relatively high dose of the neurotoxin, the titer should be increased because it's kind of a booster injection. That's what you would expect. But obviously, the immune system did not realize that the neurotoxin was injected. And this is just to show you that there is a decrease over 4 years in the antibody titer in the untreated patients. And how is it when the patients were treated, or the other collective, the other group is treated with 200 units zeomine? Well, it was the same. Decrease of the titer. Instead, what you would expect would be an increase of the titer. So it seems that the neurotoxin in zeomine is in some way hidden against the immune system. Interesting result. I asked this professor, how is it with the response concerning the zeomine treatment. He will publish that in the next future. So I'm very interested what is with these non-responders who were treated with zeomine. Are they really responding to the treatment? So again, a clinical study which demonstrates that there is really a difference between the complexing protein containing products and zeomine without any complexing proteins. Okay, if you have no more questions concerning this antibody immunogenicity subject, I would switch over to other topics.
I'm fine with this. Yeah. You remember over lunch when I asked you, how do you explain non-responders who are antibody negative? This is what Dr. Della was asking about just now. Dr. Frevert already told me we have no explanation. We know it happens. We don't know why. Is that correct?
Yeah, that's right, correct. There is no scientific explanation for that.
1% of cases.
Yeah. And well, there are no studies. Well, you have to have these patients and then study whatever your working hypothesis. For example, there is a different exposure of the receptor molecules, or a different conformation of the SNAP25. We don't know. And it was interesting for me to hear that after some time, I think you mentioned 2 or 3 years, patients become responsive again.
They can become responsive.
So that's very interesting. So what happens in the time between?
So you say that the title of the secondary non-responder, the presence of the antibodies, is not permanent.
No, it slows down.
So the body answer to a stimulation.
Yeah, it's not permanent.
Like a primary non-responder.
Yeah, you know, from the immune system, you have so-called memory B cells. A very low concentration of memory B cells, which are traveling in the blood and the lymph and so on. And to produce, again, antibodies, they need a stimulus, a booster, so to speak. And if the stimulus is not delivered, then the titer goes down. So in this case, the neurotoxin in zeomine was not a stimulus. Whereas these patients were treated with Botox and Dysport before. Botox and Dysport were a stimulus because they developed antibodies against the neurotoxin. So that's the explanation for that.
And you know if the presence of antibodies is dose dependent?
Yes. Well, this is a difficult area. It is, of course, there's a dose-response relationship.
Yeah.
But it depends on the sensitivity of the immune system of the patient. And there are some speculations about the major histocompatibility complex, the MHC molecules, you know, from the immune response course, that parts of the antigen, small peptides, are exposed by this so-called MHC, major histocompatibility complex. And so these proteins which expose the peptides have to fit to the peptides. And so it might be, there are no scientific data around that, it might be that some patients have major histocompatibility proteins which fit better to the peptides, and so there is a higher risk that antibodies are produced. And that is dependent on the genetic makeup, of course, because you have such a high range of MHC molecules. And so it depends whether, well, there's really a fitting. I have shown you some head-to-head studies. I will not go into detail. Maybe this is interesting. And I have also have a question for you concerning this. This is long-time treatment with, in this case, Boucouture, glabellar folds. 8 injections over 2 years. And so there was an assessment by the investigator and by the patients, and you can see there is no decrease of response. After 2 years, after the 8th injection, there is a good response. But if you see the numbers, there seems to be, maybe not really significant, there seems to be an increase of the response. And so I often ask doctors, do you see that in your practice? That after a couple of injections, the patients are responding better, and in consequence, that would be a consequence, you could reduce the dose which you inject a little bit. Is that your impression too? But there's a thought behind it.
I see patients in which the interval between doses increases.
Mm-hmm.
I see an increased effect upon repeat injections. I also see patients who claim they do not have the same effect over time, but they kind of get immune. Not immune in terms of not responding, but responding less vigorously. From a clinical point of view, I find it always very difficult to see a difference, because you see these patients not at a fixed interval, but when they come back for re-injections, it's very difficult.
Okay, I understand.
At least that's my...
Yeah, the thought behind it from my perspective is that in the muscle you get some kind of atrophy.
I think so.
Yeah, and maybe that was a hypothesis. If you have an atrophic muscle, the dose which you must inject could be less. That was a theory, of course.
So if you think of the treatment of masseters and of leg muscles, there you definitely have loss of muscle mass. There's no question about it. I don't like the word atrophy, but that's what goes on. The muscle loses mass. There's no doubt that this happens. I also think it has to do with plastic remodeling of the brain. That also has to go. Because when you treat patients that have labella hypertonic muscles, and who use these muscles very much, when you give them botulinum toxin and they relax, the brain remodels and stops using those muscles as much as before. And also this allows you to reduce the dose or to lengthen the interval. So there's so many variables there that it's really difficult to get.
Okay. Good.
Do you have something about the delay time comparison of the three toxins?
I have no real study about that. You mean the onset of effect? I have only a little bit theory. If you are interested in a little bit theory, please interrupt me when it's too theoretical.
Botulinum toxin have a more rapid onset. Is the cause the absence of the protein complex? Or not?
Well, there is one publication, I don't have this. I have the publication for another issue. There's a publication, a very recent publication, which claims that the onset of effect in Boucouture is faster than in Botox and in Azalure. From the theoretical point of view, I'm a little bit skeptical about that, because I have shown you what really is important is the pure neurotoxin, the 150 kD neurotoxin. This is the same in all the different products. So the migration to the motor end plates is only depend on this molecule, and the migration should be identical when you compare the different products, because it's the same molecule. Maybe it's a little bit different, because in biotechnology there's the same. The process is a product, and the product is the process. The process, and you know the process to manufacture Botox is different from the process to manufacture Xeomin and Azalure. Different processes can have an effect on the properties of the molecule. So maybe there's a slight difference, but this slight difference cannot explain that there is a difference in the onset of effect from my standpoint. There is one explanation, and I discussed it just recently in Cannes with another doctor. You know, in Botox, and I have shown that in Botox you have a proportion of inactive neurotoxin, which cannot really be taken up by the nerve cells. But maybe it can block the take-up of the active neurotoxin into the neuron. And for quite some time, it blocks the neuron, and so there is a delay of the uptake of the active neurotoxin into the neuron. That's poor speculation, I must admit, but that would be a plausible cause for that. I'm, from my standpoint, a little bit skeptical about the onset. And, well, I don't know what is your perception. Is onset of an effect, is that really critical? Because, well, the patients know. I was told by a doctor in the US, when he has a patient who wants to go to a wedding on the weekend and comes on Thursday and Friday, I must have an effect on my wrinkles in the next 1 or 2 days. Then he injects type B. A little bit crazy, I think, but it's true that the onset of effect of the type B neurotoxin is faster than type A. But on the other hand, I would not recommend to inject type. So usually the patients, I think the patients are aware that it takes some time, 2 to 3 days, that there is really an effect and they can handle it. And so onset of effect is not a real matter. But maybe you have different ideas about that, different perception.
To me, it makes no difference at all. I have never heard a patient complaining that it took 1 day more or 1 day less. I guess that can change from person to person. To get a little bit out of the immunologic and antibody response, one subject which has been very much debated by the lay press in this country is the subject of retrograde transportation along the neuron. Have you studied that at all? Do you have any data on this?
We have not studied that in detail. I'm very much aware about the publications by Kaleo and his group. I heard it a couple of times. Well, I think from the therapeutic point of view, all these data have no effect on therapy, because what he has done is to use very high doses of the neurotoxin in his more or less artificial models to demonstrate that there is a retrograde transport. And there was a recent publication, I think half a year or so ago, and this group studied, also in artificial systems, the traveling of the neurotoxin in the nerve, in the dendrites. And the velocity was very, very slow. And so from this standpoint, I think that these CNS effects, which are discussed in the press, are not relevant at all. And I give you another explanation for that, or another idea, another experiment, if you want. There was this criminal case in Florida quite some time ago, where this doctor couldn't calculate right, and he injected 1 million LD50 units into patients and into himself, and so all these. It was more or less a party. And It was.
What the toxin in
I mean.
the laboratory.
Yeah.
And he messed up the dilution.
Yeah.
And he wasn't a doctor, by the way. He was an osteopath.
Osteopath.
And he had already lost his license as an osteopath because of other problems he's had before. And not being happy enough with his previous problems, he created more. And he gave lethal dose to himself, his girlfriend, and to two very close friends of them. And they saved their lives in an intensive care unit for 4 months, intubated, until they were taken off the respirator. And he went directly to jail, and the other 3 went directly back into normal life.
Very strange case. But my point is, even in this high dosage of botulinum toxin, really high, I mentioned that it was several hundredfold more than the lethal dose for a human. In this application, there were no CNS effects. And well, if you compare that to the low dose which you apply in your practice, well, then CNS effect cannot play any role at all.
That's a very good point.
So that's very plausible to me. Well, yeah.
Nel botulismo non ci sono effetti di sistema nervoso centrale, è solo periferia.
Quindi comunque qualunque viaggio possa fare la tua tossina botulinica comunque non ha effetti. È dimostrato nella patologia, non lo dimostra.
And so from this standpoint, I think well, these experiments are very interesting. And well, Khalil had the idea to treat epilepsy with botulinum type E. So that was the idea behind it. And I think that's a good concept. And so I appreciate his work. But for therapy with botulinum type A, it doesn't play a role. So that's my perspective.